Hello. Hey, today we'll be playing a game called TIS-100. Quite a programming game actually, to be exact. For everyone, I think. But still, fun to actually try and play this. So, well, in a way, you need to know some basics of programming in order to actually play this game. Whoever was like interested to know. Yeah, there's a quite advanced documentation follow to actually play this game. So yeah, see how it goes. Not sure if the stream is gonna work properly. We'll know soon. Not soon. Yep. So if you can see, this is actually the main menu of the game itself. Moment when you start, this is what you will see. There's a quite extensive documentation that comes with the game that you will need if anyone's planning to play the game, because you literally have to follow documentation to play it. Yep. So my stream is working well currently on Twitch and YouTube. Seem to have a bit of an issue on side. Let me try and get that done. Resolve that, then we can start. How does this work? Add slide description. Okay. So I think we are live now on 3 different platforms. So yeah, let's see how things goes. Live on Facebook, Twitch, and also on Facebook. I might not be able to follow the comments on each because I would have to refer to documentation as well, using the other computer for that. Okay, so before we start, let's just show you how the documentation looks like. Let me have to switch it to this. So yes, this is the documentation of the game. You see it's a PDF file, has quite a number of pages, a few pages to be exact. So yeah, you go through it, you go down, it's basically showing you what each function does, but you know, don't worry about that first. I'm just going through like to show you like there how many pages of it. There's about 12 pages, 13, 14, yeah, 14 pages of it, but we don't have to worry about it yet. We'll worry about it once we start. So let's do that. Back here. Okay, so what's the background of the game? Basically, this is a computer that has broken down, to be exact. Okay, a machine that's broken down, it doesn't work, something has went wrong with it. So our job now is to fix this machine, get it back into working state. And how we're going to do that is to actually reprogram certain functions, certain parts of it, the cores that have broken down. We reprogram it and get it back into a working mode. That's the whole gist of what this game is about. So, yep, without further ado, let's go and start our first map per se? Actually, I think it's called cores or segment. I think the word is segments. So let's go with the first one, self-test diagnostic. So the first thing you need to press, of course, we need to create new program. So that's the button we're going to press. Oh, there we go. Here we are in the game. Okay. So anyone looking at it is going to be like, what the hell is this? So yeah, what is this about? If you're wondering, this is literally what the game is. So you code, if you think of it, in these boxes here. You type in your code. Basically, your idea is to get your whatever things that come in to go out from here. So in, for example, here it shows you an example. In X means this is the first input here, and it needs to come out here. So whatever that goes in from here needs to go through all of these boxes and come out here. Same thing on this side. So in A, out A. So it comes in and in A, goes out A. So that's actually quite a story, a background here. If you see here, can't find a pine right now. I'm just going to take notes here. Looks like a short-term storage. Got this one at a swap meet today. Fella wanted 450 for it, but I talked him down to 200. Good deal. No idea who makes this thing. Never heard of the TIS series and architecture. Doesn't look like anything I've seen before. Ask the guys down at the... I don't know what is this, but no joy. Randy has a mystery on his hand. So yes, someone just got this device, basically a TIS-100 device. No idea what it works, how it works. And now we're gonna figure out how it works. Okay, so here is a sample of the code. How to bring things from up all the way down. So if you get the idea of it, is move up, down. If anyone has any idea of how assembly works, this is how it actually works. So I'm moving something that's coming in from up, and I'm moving it down. So move up, comma, down. So I'm taking whatever that's up here, moving it down. Same thing, I'm moving up, down. So I'm moving and taking whatever that's up here, here, and moving it down to this box. Same thing here, whatever that's up here, move it down. So that is quite clear. And yeah, that's quite clear. So in a way, we will know what we need to do on the other side as well. The in A, we are gonna have to take whatever that's up. You know, actually let's just run the program and see. As you can see, yeah, what is gonna happen is it's gonna take the 51, okay, in X and out X. It's expecting a 51 out on the outside. Same thing here, int A. So it's expecting whatever comes out on in out A should be 68 as well. But then, because we do not have the code here for it yet, it doesn't work. So now the idea is, we need to create it. How are we gonna do that? Well, now we can go back to the documentation. Actually, for this task, we don't even need to look at documentation, but I just want to show how it really works. So we come back to here. So if you look at the documentation, let's go down. The most basic function we're gonna be using here is here. Left, right, up, down. I think I should zoom in a bit, yeah. Okay, there are 4 registers, up, down, left, right. So basically those are referring to the boxes, each other there, okay? And then, some ports will be disconnected, certain nodes within the hardware. So as you can see, some of it is written a communication failure earlier. Let's switch back here, yeah. Those boxes, we can't use them. So, we're gonna have to do to go around it. So the idea is, as we go around it, we have to move things. Yeah. So, okay, never mind. Now the documentation right now. Let's just solve one and see. Okay. Just need to double check if all my streams working. Yep, everything's working here. Everything's working here. And here. Okay, good. Stream is working. Okay, so as you know, the data is coming in from up, so we need to move up, comma, and then we are moving it towards the left hand side, so left. So let's just show how it works. Let's run the whole thing. So you can see 15 what comes in here, 59. Okay, actually no, the first one was actually 68. So 68 came from here, went here, but nothing is to receive it at the moment here, that's why nothing is happening. But as you can see, whatever that comes in here is being moved towards the left. So let's continue it. We are taking whatever that's coming in from the right hand side now. The box that we are taking from is right. So move right, comma, and we're moving it down. Then here we are repeating whatever that's here, basically. Move, up, down. Move, up, comma, towards the right. And lastly, we are moving whatever that's coming in from the right, sorry, from the left, downwards. So move, left, down. And now we can run the whole program. It should work. And as you can see, it's working. How do I know it's working? Well, you can see the numbers. Never mind, let's just continue first. 51, 51, that's what output is. 68, 68, that's the output. So whatever that's coming in is going out at the correct way. So it shows that this program is working. You can actually monitor it and you can see it from the side here. So it must match. Like 11 must match 11, 54 must match 54. Once it matches, then you know it works. So this one is showing you how many cycles. Cycles meaning, if you think of a CPU, how many instructions does it take to get something to work. So each of this box counts as one instruction here. So yeah, I mean sorry, cycle. Yeah, cycle. We're one of in low end here, so it's okay. We are this is a quite efficient program because it's very direct. So let's go to the next segment. So the first one was a self-test diagnosis. Phenomenal, everything's fine. Let's go for the second one, signal amplifier. What do we need to do here? Okay, from what I can see here, it's written on the top here actually, what you need to do. Read a value from int A. So read the value that's coming in from here. Double the value. Okay, what do you mean by double? It means whatever you get from int A, that's why it's called signal amplifier. You're amplifying the signal. You're making something that is from 1 become 2. Whatever that's 2 becomes 4. You're amplifying the signal. So read a value from int A, double the value, and then write the value to out A. So where's out A? Out A is here. I need to take whatever that's coming in from here, and when it goes out here, it needs to be 2 times the size of what came in here. Okay, so to do this, we need to actually work out on how best this works. Oh, and let's see what comes here. Okay, continues to baffle. Chatted with Bernie and IBM, and he says it sounds like something they ONA come out in the USSR, but why is the manual in English? So they suspect that whatever they created here came from the Soviet Union. Why is the manual in English? They could not understand why is it that. But no matter, doesn't concern us. What are we trying to do? We're trying to get this to work. So okay, to double it, so what's the thing we need to do if we want to double something? We need to multiply it by 2. And what's the best way to multiply something by 2? Okay, this needs a bit of thinking in a way. Because we're dealing with assembly. Let's see, let's go back to documentation and we should scroll a bit. My apologies, the screen, this one is black and this is white, so I think it'll be quite glaring for whoever that's watching. My apologies for that. I need to do something to turn this dark theme. How do I get a dark theme for this? I'm using dark reader. Okay, hold on one second, let me try and see what I can do. Give me a second. Let me try and turn this documentation into a dark color. Let's see. Need to make this. Wait a second. Turn this. Hold on. Seems dark reader doesn't work with PDF files. Okay. Can I do? Can I do? Oh well, I think I can't really do much at the moment about this, but just bear with me. Maybe I won't change to the documentation. Okay, never mind for a while. Okay, here. So here you get some examples. For example, for the move command, we are moving something from something else. So mov 8acc. So that you are moving the item in. Okay. Now we need to double it. So in a way, we have add, we have subtract, we have negated, jump, if 0, jump not 0. Okay. There we go. So in the example programs, we have something that can actually do this doubling already. So if you look at it, first, okay, example, move left to ACC. So basically what is ACC? ACC is a register. A register is a piece of memory which stores a value. You can use it to store data basically for a short period of time. Then what we're doing here, add ACC, meaning we are adding whatever that's in ACC to itself. So add value in ACC to itself. Yeah, adding it to itself, and then that will double it. Then we move ACC towards the right. So that is what is an example. We can do something similar here. So let's go. Oops. Yeah, let's come back here. So we can use back the exact same idea as that. What we need to do is take the value from up. So move up, and we need to move it into the register, sorry, the ACC register. And then from the ACC register, what we need to do, add it with itself, so it get doubled. Add ACC, adding it to itself. So basically, where does the result go? It goes back into ACC. So when you add something to, let's say you add a number, for example, add 1. It basically means I'm taking whatever in ACC, the current register of ACC, adding 1 to it and putting it back into ACC. That's what add does. So you actually have two registers that you can play with. One is back and one is ACC. What we are doing, we are just playing with ACC now. So we add it to itself, and now we need to move it down. Actually, we can either move it right or down, either one. Doesn't matter, but we're moving it down for now. So move ACC down. So if you think of it how it works, we are taking the value from up, move it to ACC, then we add ACC to itself and put it back into ACC. Then we take whatever is in ACC and move it down. So here, whatever value we have will be the double of what came in A. Now we need to move it down again, and then towards the right and down. That will end this one. So move up, and we can move it to the right as well. Towards the right. And then from here, move left, down. Lastly, move up. Oops. Oh, right. It's MOV. Move up, down. And this should work. But now let's show you one more thing that we can actually do. Called step. What do I mean by step? If you look at this whole thing, right, when you press run, it just goes and runs everything. That means I want to just try one. So let's just step one and see. Step. So it shows you that, okay, first thing it does, takes up, move in ACC. We step it again. So it tells you now it's reading it, and it's not doing anything else. So it's taking the 66 now. Take the 66, move it into ACC. So it's now and it's moving it there. So it just did the move. It hasn't added now. When I step it again, it will add. You will see the result come in here. 56 becomes double of it. It's 132. So you run it. See, it becomes 132 here already. Now I take this 132. I move it down. So you see the value here? 132. That is double value. Step it again. 132 now comes here. Tap it again. That 132 now comes down here. And one more time. There. 132 is the output. So you can see 132, 132. So we're getting the correct answer. And now we can actually finish it off by just pressing run. There we go. So the idea is we must make sure that all of the numbers here matches. That's how you know whether you're correct or wrong. There we go. So this is actually one of the most simple ones, you know. This is the simplest we can do actually. The signal amplifier. Yeah, basically this is what the signal amplifier is. You're actually magnifying or amplifying whatever signal that's coming in. Doubling it. Can be less, doesn't have to be double, but in this example we're doubling it. Okay, so now we have a few more that we can actually do. So let's go for differential converter. So what is a differential converter? Let's go in and see. Read values from in A and in B. So you have in A here and in B here. Write in A minus in B to out P. So as you can see, you have out P here. Write in B minus in A into out N. This sounds very familiar. Okay, so how it works is you're taking a value from here, you're taking another value from here, and you're basically taking the difference. So the output of P and N will be the difference of these two in A and B. Okay, so in the out P will be basically A minus B, and then N will be B minus A. Whoever that does programming would probably know what this is, or even electronics to be exact. It looks like there is some kind of static memory in this thing, encoded or something, or other. Interesting. Okay, let's go on. So how are we going to do this? This requires a bit of thinking. So actually, if you look at it, here I have some examples. So how it works, okay, let's look at it. 44 minus 93, what do you get? Negative 49. 93 minus 44, you get 49. So that's how it comes out. You see 43, 44, 93, 49, negative 49. 93 minus 44, it's 49. So one is negative, one is positive. So that's how you determine whether the answer is correct or wrong. Give me a second. Give me a second. Yeah, I'll be back in a second. I got a phone call and didn't answer. Hello? Yes, my apologies. Sorry that call went on a bit long. Okay, right. Where was I? Right. Okay. Yeah. In A and in B. So we need to basically the output is a minus of each other, and yeah. So what are we gonna do? Let's go through the documentation again. Always refer the documentation. Okay. Let's see. So there is an add function. In Wave, this is exactly like assembly language. Oh, actually, I forgot that there's a button you can press in the game itself to actually show this. Let me just show you that first. So if you press F1, if you have the game, it shows you the instruction set. So NOP, no operation, doesn't do anything. Okay, move, source, destination. So you're moving from the source, wherever your source is, like left, right, up, down, to your destination. Swap between ACC and the back. So you have two registers, you can swap them. Save. So you're taking whatever in ACC, move it to be the backup register. Add means you add it. Subtract. Yeah, that's the one we're going to be using. Subtract. Source from ACC. Negate. Okay, what does negate mean? Okay, let's go back to the documentation. Negate means, in this case, negate. Oops. Negate. Oh, where's that? Oh, by the way, yeah, one thing. You can't access the back register directly. It cannot be a source or destination. It only can be used with save and swap. SWP. Okay, whatever you call it. Okay, and then you have labels and nope, okay, move and swap, save, add, subtract, negate. Okay. Negate means arithmetically negated means it turns it into 0. Yeah, it just makes it into 0, that's what it is. Okay. So right. Come back here. So in a way you have the subtract function. So what you can do is basically use that. So we're taking whatever that's coming in from A. So very important is take them first. So move A. Sorry, not A. Out. We're gonna move it. Okay, let's see. We take the value of A, and we probably, if we want to do calculations with it and I think we need to move it into ACC. So let's move it ACC. Same thing with B. So we take move B. Okay, if you think of it, we need to actually use both of these. Why am I keep saying B? It'll be up. And then we need to take the value. Yeah, basically you need to do the calculations on two different places. Here, probably here. Okay, move it from up to ACC. Okay. Yeah, let's move both of them to ACC first. Then we think of what next we're gonna do. Okay. Next, with whatever that's in ACC, we need to take whatever's on the other side, which is A. We need to take whatever's in B. So move ACC. Okay. And we're gonna move it to B, which is on the right hand side, because it needs a copy of it as well. So what we're gonna do is, and here is where the subtraction can take place, because now we can actually use that value of B, of whatever's coming in A, sorry, and use it to subtract from A. But if you think of it, if we do that directly, whatever that is, or the original value that's in ACC is gone. I can't do anything with it anymore. So there's probably two ways we can go about it. One is we can probably move the original value of whatever that's coming in up, down first. Let's try that. Move ACC down. So think of it, I'm trying to keep a backup copy of actually no. Uh, Actually no. Sorry, that's no. Move ACC. Or actually, I'm supposed to save it first. Wait 1 second. Let me just refer it. Save. Okay. Yep. So I'm gonna do a save function. I'm gonna move whatever that's in the ACC into the backup memory. Back it up. Okay. Save. And then now whatever is coming in from the right hand side, or left hand side, sorry, in this case, yeah, on the left hand side, move, not move. I'm gonna use function called sub. So if you see the documentation, sub means I take the value that's coming in from source, in this case will be left, and I'm going to do it, I'm gonna subtract it from ACC and then store the value back in ACC. So how does it work? Let's just do a step function and see. Step. Okay, I take the value 4493, step in again, so this 93 now goes into ACC, and then I'm taking same thing here, 44 goes in ACC. I'm taking now the ACC, that 44, and moving it towards the right hand side. So if you run it, step it again and see, yeah, this 44 is now on here, left hand side. Okay, this one has moved in the backup already, so there's a backup of it. And if I step it again, you look at ACC now. ACC is 49. So it has the answer 49 here now. So it's correct. ACC is storing the correct answer, which is the output for out n. I have to do the same thing now for this side. Let's stop it first. So I sub left. Then whatever answer I got there, I need to move it down. So move ACC down. And if you think of it, I need now to take back whatever that's the value in the backup, put it back into ACC. So basically the same place here. So what I need to do is, there's a function called swap, SWP. So SWP, take back from the backup, move it back into ACC. And then move it back to ACC, and then I need to move it towards the left. Move ACC left. Okay, now on here, this side, I'm taking whatever that is coming from the right hand side and subtracting it with ACC. There, move it back. Yep. And then move ACC down. So let's step through and take a look at what happened. Okay. So what comes in? 44 and 93. Makes sense. 44 and 93 are in the ACC for both. I step it again. Okay. Now I'm taking whatever that 44 is coming in from this side and then subtracting it with 93, I get 49. Okay, so this one, sub ACC now, is just waiting for something to come in from this side. So I could step. Oh, right. I have an issue here. Because move it down, there's nothing accepting it here now at the moment. Okay, it's waiting for something. Oh, okay. So that means I need to put some... You see what's happening here is, it doesn't actually wait for something to come in. What happens here is, it sees there's nothing coming in, so it assumes it's 0. So it's actually subtracting it with 0. So it turned everything into 0 here. So what I need to do is, stop it. I need to accept something. Let's move up, down. I'm just going to do that first for all of them, please. So I know the answers will go down, up, down. I'm going to just do all of it here like that. Up, now that we have that, let's just go through and see. Yeah, the 49 goes down. Okay, this is stuck. Okay, swap. What happens here? That 93 comes back up here. So 49 goes down there. 49 comes down here. So 49 is correct. Okay, that 93 comes back here. And I'm taking that 493 and moving it this side. Step back. That 93 comes back here this side. There we go. Although we do have a problem already. Because, yeah. As you can see, here's coming out with 0. Not the correct answer. But now you see that this 93 comes right out this way. So one thing we do have to take into account, especially when dealing with assembly, is the timing. So the timing of all of this is all wrong. Because the values are not coming in correctly now. Okay, if you look at it, what we need to do now is that's why we need to probably use the NOP. My program at the moment is not very efficient, that's for sure, because I can make use of the other boxes here. There are like all these boxes I can make use of, but I'm not using them, unfortunately. So not very efficient. Like I just have to put some NOP values here so that it makes the timing the same. So probably I need to put in, let's see how many. I need to know how many cycles it is using. Let me just put 1 first. And let's take a look. Tap it. 493, okay. So I moved it there. That's taking 2 cycles, I think. Subtract with left. Don't do anything. Move it down. That moves down. Then now it's trying to take a value from here. But there's no value to it because it's still only moving it down. So I need to put another 2 more knobs there. Something like that. Yeah, we will adjust the timing later on. Just make sure it works first. Very important. No point in it doesn't work. Okay, let's just stop it. Oh no, it stopped. Okay, step 1, 2, 3. Don't do anything. Move it down. The timing is still out. Haven't done assembly in a long time. You know, this is a very inefficient. Okay, that 93 comes in here. This takes the 93. Oh wait, something's wrong. Let's see. ACC. Move ACC to the right. 44 is in ACC. Okay. Don't do anything. Don't do anything. Don't do anything. 93 is coming in. Subtract by ACC. And I end up with 0? Why do I end up with 0? Oh, right. Using the wrong function. I'm not supposed to sub ACC. I'm not supposed to take the value from the right. Taking the value from the right hand side and subtracting it with ACC. So basically what I was doing is I was subtracting ACC with itself and became 0 obviously, because if you had 1, your minus 1 is obviously becomes 0. So yeah. Let's do that again. A step. Go, 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 go. Okay. Okay, move down. So negative 49. Yeah, we got a correct answer here. Let's go. Step. Negative 49, go down. Okay. And that 60 comes in. -18. Okay, I just realized that I do not need all the NOPs. It actually waits. Because my problem with the subtraction was I was subtracting wrong thing. Okay, let's try that again. Let's go. So yes, the answers look correct now. -18, 18. Yep. 4, -4. 27, -27. Okay, good. All answers are correct here now. Now we can just run it. So out P is obviously slower than out N. The reason being there are more instructions here than here. I mean, there's probably a way to make it more efficient, but I can't think of any at the moment. So let's just get it working first. Oh yeah, it works. The answers look correct. There we go, it works. So yeah, as you can see, this is not the most efficient design. There are better ways of doing this code. We can do some optimization, but I don't think that's the purpose of today's stream. Just gonna get this working. That's the main idea today. Yeah, we'll try and optimize this later on. Okay. Have I seen this? Ah, yes, I have. Static memory. So yes, let's go through fast. Okay, done. Where the segment list? Okay. So differential converter, yeah, that's what it is. The difference between two. Okay, next, let's go for signal comparator. That. So our input is here. Write 1 to out G if in is more than 0. Write 1 to out E if in is equal to 0. Write 1 to out L if in is less than 0. So in a way, in programming, this is what you call a if then L. Yes. You're taking if is coming in is larger than something, you're giving output here. If not, the output comes here or here. Yeah. So actually there's nothing to do in these first three columns. We'll debug and see. Found a block of static memory, but it's a proprietary format I never saw before. Can't make head or tails of it. Oh bother. There's just too many different things, different kinds of machine coming out now. I like tinkering with them as much as the next guy. But when every Tom, Dick and Mary implements their own memory address scheme, it's all... I'd say the bottom's going to drop out of the microcomputer market soon. Mark my words. Well, in a way, yeah. Okay, whatever that's supposed to mean. Okay, let's see. So, I think of some idea how this works first, huh? So, three functions come in very handy here. So, let's go and open this up. We have jump if ACC equals 0, not equal to 0, okay, more than 0, and less than 0. So we're making use of labels now. Okay, so basically in a way, if you think of it, it's like I want to run a piece of function, like, you know, we make a custom piece of function that we will go there if it matches certain conditions. So the idea is this, we'll be checking for these few things here. Equal 0, not equal. Okay, we're not going to do not equal 0 probably. Let's go less than, more than. So yes, let's go and do that. So don't bother about the rest of these. We're going to go down straight here. Move. Up. Down. Move. Up. Down. Move. Up. And we're going to the right. Okay, now here it's where we're gonna actually make do with doing the checking. So out G, if the input is more than 0. So we need to check if this number is more than 0, then it comes out here. If not, it goes this way. Make sense? Okay. So more than 0. So jump to label if more than 0. That's what we're gonna be using. We're gonna put a label. So how do you do a label? Oops. That. Yeah, I can't move my mouse out of the screen. Oh, never mind. This. So how do we do more than 0? And how we do labels? So if we look at the examples given, we can actually make a label like this. So you have start, positive, negative. So yeah, this is one of the examples we need. Really? You look at it. So what I can do, we can probably make a start label as well. Start. Label is up to you how to name it. Basically, it's like the name of a function. So, in a way, what you're gonna need to do here. Okay, start. We're gonna check. We're gonna take whatever is coming in from the left hand side. Move left. And then we're gonna move it where? ACC. Obviously. I'm gonna put in ACC. Now, if the value of ACC is greater than 0. So when we're checking, we are checking it's more than 0. So yeah, that's it. That's one we need. JGZ. Okay? Jump if greater than 0. JGZ. Now we need to put a name for the label that we're going to jump to. So the label we're going to jump to is probably going to, I'm going to call it pause, okay? Jump if more than, yes, of course it's undefined because I haven't created it yet. I'll do that after this. And then if it is not positive, if it's not greater than 0, I want to move it to the right. So move ACC to the right. And then pause. So basically this is like saying, yeah, starting, I want to do this. If it's not, go to pause. Then here, move ACC to the down. Oh right, of course we have to go back to start or else we'll be stuck here. So jump JMP. Oh sorry, I forgot to change back the screen. Yeah, so what I did here is I moved left to ACC and then I'm checking if the ACC value is more than 0. If it is, jump to the label called pause. Or else, move whatever that's in ACC towards the right. And lastly, of course, I need to make sure that this program starts again. So I needed to jump back to start. Same thing here. So JMP start. There we go. How do I know it works? Let's go and step through this and see. Okay, so input is 2. So 2 is coming in. It gets moved down. So 2 is here now. Gets moved down again. Okay, move down again. And moves towards the right. So we are waiting for whatever's coming in from the right. Step through. Take the value of left. Move in ACC. So ACC has the 2 now. Now I'm checking this number bigger than 0. So it is. So it's gonna jump to pause. There, here we go. Then we move ACC down. So the output here has 2. We step again. It goes back to start. So, oops. Oh, right. I'm supposed to write 1 if it is greater than 0, not take the value and move it out. Okay, so I'm supposed to move 1 down. Right. I misread this. Okay, let's do that again. Let's go. Okay, move 1 down. There we go. 1 step. There we go. We have 1 coming out. So now it's correct. Okay. So yeah, next time you one idea is to read the documentation the instructions properly. Okay. So we're gonna do something similar here as well. Start. the same thing, move whatever's left hand side and to ACC. You can copy everything. It's okay lah. Now for E, out E, if it is equal to 0. So next one we have to look at, let's refer back to the documentation. Jump if 0. Okay, so J, E, Z. That's the one we need now. J, E, Z. And then we're gonna jump to, yeah, let's call it 0. Yeah, undefined label because we haven't created it. We'll create it after this. If it is not equal to 0, we need to move it towards the right hand side. So move ACC right. And lastly, jump back to start. Obviously, we need to make sure that this program restarts itself. MP start. When A1 is not written, it's not written to an output, write A0 instead. Oh, okay, so even if right, so even if it is not 1, even if the answer is not correct, I should write something. I should have an output for it as well. It should be 0. Okay. This is, like I said, the problem. We don't read everything out. So when A1 not written to an output, write a 0 instead. When a 1 is not written. So it means that in this case here, like just now, when 2, first one is 1. So the other two should come out as 0 instead. Okay. So yeah, I will add that in a sec. Let me just finish off the same thing here first. So 0. Move 1 down. And then JMP start. Okay. Now I need to write 0 if it is not. So in a way, it should be here. Oh, means no matter what, I still need to write to the right hand side. I need to copy this. Can I copy this? Control C. So this should be done before I do the checking, because all of it needs to do it. I just put this here. Right. Okay. I will take this out here. Move 0 down. So if it's not positive, and I move 0. Same thing here is, let me just paste this here first. Right. Then I need to move 0 down. Okay, let's step through this and see. Run. 2 coming in. So ACC has 2, correct? Now I'm gonna copy whatever that's in ACC, move it to the right as well. So right has the same value. So here, yeah, the ACC is 2 as well. Okay, now I'm checking. Is this positive? Yes, it is. So I come here. Ah, right, this is not gonna function here because, never mind. So I come out a 1. So this is not gonna be 0, so it's gonna be coming down here instead. I need to actually, some code here. Okay, never mind. I'm gonna copy everything here first. Copy and paste. And let's just finish the last one as well. So this should be negative, NEG. Okay, and then let's see. If I'm doing negative, I need to use the J less than 0, JLZ. So jump less than 0, JLZ. Actually, this whole thing should work now. This is, but then we step through and see. Step. So okay, 2. Okay, move. So okay, 2 is coming here as well. Yep, 2 is here. Go out here. 2 goes there as well. Okay. Yeah, move 1 down. That works. So it's checking now. Is this 0? It's not 0. So move 0 down. So yes, I have 0 coming out now. Move this O. Oh, right. There's no right here. God, can't just copy paste everything. No right to move here already. Remove that. Try that again. Step, 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 step. Oh, we know this one works. Step, step, step. Okay, move 0 down, move 0 down. Okay, this is working as well. So basically, because if this is true, the other two is false. Move it down, so 0, 0. So as you can see, 1, 0, 0 is correct. Try next one, 1. So same thing, 1. This will be correct. So this will be coming out 1. So 1 is coming out. The other two should be 0. 0, 0, there, 0, 0. So it's correct. Okay, the next one is coming in here. Is a 2. Yep. So as you can see, yeah, same thing should happen. 1, 0, 0. That's the output. And the next number coming in here is 0. So this should be 0. This should be 1. So 0 is coming out here. Yeah, it's coming here now. This is still 0. This is 0. Okay, correct. So the output is 0, 1, 0. That's how the output should be. So yeah, let's just run through it. This should work quite well. And there we go. So cycle counts 278. Well, it's okay. It's okay. This one, yeah, it's fine. Instruction count statistics. Apparently, I can still make it a bit more efficient. That's okay. That works. So yeah, let's do one more. I think yeah, one more is good enough for today. This game requires a lot of thinking, so long day, so I'm not gonna do too much. Let's do this one. Okay. Read values from in A and in B. So A, B. And then read a value from in S. Okay, I'm gonna take value from A and B. And then I'm gonna also take a value from S. Write in A when in S equal -1. Okay. This is basically it's a switch. Basically, you're switching between the two outputs. If your in S is a positive number 1, I'm taking the value from B. If the value from S is negative, I'm taking the value from A. If it is 0, then I add the values of these two together. And that is my final output here. Okay. Hey. What does it say? I might have an idea of where this TIS-100 machine came from. Something, describe the architecture. Read the Motorola, at Motorola, and he says it sounds like it was designed for signal processing. That got my brain going. Government project, maybe. Something the CIA cooked up to comb through Soviet radio signals. Hush, hush, top secret. Maybe I could be possession of a classified device. Something for spook. I'm gonna sit on this one for a little while. Interesting. Someone decided to encode their own memories into the game. Or to the microcomputer per se. Right. So we're gonna be using back whatever that we have used just now to actually figure out the values here. Okay. Let's think of how we're gonna do this. So I'm gonna be having a function here that's gonna be checking the value that's coming in from here and then jumping to different labels depending what value is coming in. Okay, let's try that. Okay, I'm gonna just move everything. I'm gonna use this box for most of the processing, I think. So let's take move up, right, and then we're gonna move up to the left. Okay. Now we're gonna move up and we're gonna move it into the ACC register. Very important, we're gonna move it somewhere that we can do things with it. Next. Oh, I forgot, we need to put a label for this, of course, because that. Okay, and then we're gonna move another. We're gonna do 2 more labels. Actually, 1 more label is gonna be called pause, and then another one is gonna be called 0. Another one, neg. So positive, 0, and negative. Useful here. Okay. Now we need to check the value that's in the ACC. Positive, negative, or 0. So jump greater than 0 to pause. Jump JEZ, I think. Let me just double check. JEZ, yeah, correct, yeah. Jump JEZ 0. Okay. Lastly, JLZ negative. So, and then after that is done, of course we need to go back to start. So JMP start. Okay. Now, what to do in positive? If it is positive, I need to take the value that's in B. Move left, down. Make sense? Yeah. So we're taking whatever that's, hey, sorry, not left, right. We're taking from in B, yeah. Right. So if it's positive, I take the value of B. Yep. And move it down. Okay. Now the question is, what can we do? No, if we're moving that, we need to do something about the other values that are coming in from the other value that's coming in from the left-hand side. So let's see, what can we do with it? We need to move it somewhere. Okay, we can move it to nil. That's what we can do. So move left. So basically, we take right, we move it down, we take the left and then just throw it away, move it to nil. And lastly, of course, we need to jump back to start. Obviously. Okay, next, 0. For the 0 one, okay, write A plus B when in S equals 0. So, idea here is we need to take the value from both of them, add them together, and then move it down. So, take the easiest way is, of course, we're gonna just move it into the ACC. We don't need the ACC value anymore, so we can replace it. So move. Let's take A first. Okay, so left, and then move it to ACC. Oh, we have a problem. Not enough space to put more code here. So, in a way, this is why we have so many boxes. Okay, let's see what's the best way we can do this. Okay, since I can't put all the code here, now we have a constraint. Yeah, I fit all the code in here, so I have to make use. Yeah, okay, makes sense. I'm not supposed to use one box for everything, so let's see. Best way I can do this. Oh, that makes sense. So rather than moving everything here, if it's not true, I can make use of the other two boxes here and here. You know, to let's say do the other processing. So if it's not, here can do processing for like higher number. Okay, let's see what's the best way to do that then. I'm currently moving everything to the right here. Oh, okay. I know how to do this now. These two boxes can be quite useful in this case. Because if it is -1, all I need to bother is the value from here. So this can go straight down. It's only when it is actually 0 that I need to bother by adding it up. So basically the discarding and everything can be done over here itself. I don't have to move everything towards the right or the left. Okay, so let's move this to the ACC. So move this ACC. Move this to. Yeah, I need to move this. Wait, no. I need to do the checking from the left. Whatever's coming on right. Okay. Let's take out all of this. Let's take out all of this first. Move up to ACC. That's fine. That needs to remain there. The middle one, I am only gonna bother when it is 0. So I'm gonna jump when it is 0. If not, I don't bother. But while doing that, I need to also take the value from here to move it to the other two sides. So move up to the left and also move up to the right. Okay, that makes sense, right? It moves to ACC. No, actually, no, not up. If I keep doing up, it's gonna take new values in, and it's gonna be all wrong. So I need to make sure that's in the ACC register. Okay, then jump when it's 0. Okay, and I'm gonna remove now the positive and negative part. Don't need that here now. 0. Okay, move left. Okay, let me finish this one. Move left to the ACC register. Yeah, okay. And then I need to see that there's a function for subtract source from ACC. Okay, so maybe no, that's subtract. I need to add, yeah, add. And I'm gonna take the value now. I took left, so I'm gonna take right. And it was saved back in the ACC. And lastly, move ACC down. That makes sense? Yeah. Okay, now what to do here? So since I'm taking values from here and moving in here, okay, so I'm not gonna bother with up first. So I'm gonna need to see what value is coming in from the right hand side. So move right ACC so that I can see whether I need to do anything with it or not. So same thing here. I'm not gonna move up now. I'm gonna move whatever's coming in from the left hand side. I'm gonna move it to ACC. Okay, make use of the ACC. And then, oh right, I will need to actually use labels as well. Start. Yep. And a label here. So long since I did anything in assembly language. Okay, yes, move whatever that's in the right hand side into ACC. Now, I need to check if this value in ACC, it is for A, if it is less than 0. So I need to jump less than 0. J, L, Z. And I'm gonna say negative. I'm just gonna create that as well. NEG. And then what do I need to do if it is negative? If it's negative, I will not do. That's another good question. Now, what do I do when it's negative? Move it down? If I move it down, then I will need to have another logic down here. So actually now, see which value do I want to take. Because I have to compare it again now. I need to compare the values out. Which value am I going to take? Okay, never mind. Figure that out after this. Negative. What am I going to do when it's negative first? Negative. Okay, I just move it down for now. Move. I'm gonna move whatever's up directly down. Does make sense, right? If it is negative, then I take. If it's negative 1, so it's negative value, I take whatever's coming from A and move it down. Yeah. If it is not, move up to nil. Yep. And then jump start. And then here, I need to. Anything else I need to do here? No, just jump back to start. Okay. So in B is gonna be nearly the same. I'm just gonna copy all the code here. B, everything, backspace, paste, and now this is not going to be right, this is coming from the left. So move left to ACC. And then now it's not going to be negative, this is positive, pause. And then not less than, this is going to be greater than. And then this is pause. Okay, and move up, down, jump start. So it's the same thing here. Now, next question. What are we going to do? In a way, we can do a bit of checking. Check the value coming in from here. If it is because it's not going to output anything if it's not. So I probably want it to output something even if it is empty, so that I can compare, for example here, which value I want to take. So I can say if it is nothing, I can output a 0, and then ignore it if it is a 0. So if this is not a 0, then I take the value from here and bring it out. Yeah, I can do that. So basically I do like another comparing. I compare this tree now, because all three is going to go down. Comes down here, this comes down here, this, and then I make them all come in here, and then I'll see, is the output of this 0 or not? If it is 0, yeah, okay, we can try that. Okay, so what I'm going to do is move up to nil, jump to start. Move up, down. Okay, then I will instead, in this case also, move 0 down. So in a way, if it is not negative, if the value of s is not negative, okay, I'm moving 0 here. What happens if the output is 0? I think it doesn't matter if it is 0. Never mind, we'll see what happens when it happens. And jump if 0. I'm going to do the same thing here. If it is 0, or I should do it here. I'll be checking each one of these. Move 0. I'm probably not thinking properly. I'm probably missing something, but yeah, let's just see how it goes. Let's say it's not exactly very easy. A lot of thinking needs to be done, honestly. Okay. Move up towards the right. So this box is not really gonna do anything. Move up to the left. And here, finally, it's gonna do the actual processing now. I'm gonna first check. I'm gonna move whatever that's on the left hand side. No, okay. Move left. ACC. So I'm checking now, left hand side. Okay. And then I'm checking whether it's 0. If it is not 0, so greater than 0. Wait, that's a problem. If it is not 0, But what if in A is 0? Then I have another problem. I'm probably not thinking enough. Never mind. Let's just see if there might be conditions that this will have an issue, but let's deal with it when we encounter it. Start. Move left ACC. 0. Then we're gonna say if it is 0, we jump to let's use the word P, or I'm gonna use the word A. So say this is supposed to be taking output from greater than 0, or jump not 0. I think J and Z, right? J and Z, jump not equal to 0. Yep. A. Then what I'm gonna do? Move left. No, ACC down. I am sure I'm gonna encounter some weird cases when I do this. And move up, down. I got a feeling I don't have enough space to do the whole thing here as well. There's something wrong. This code is really not efficient, I gotta say. Well, that's where refactoring will come in later. So let's just see what we can do. So B. Actually, no, I don't need a third one. I will just need to move up, down, start, come back to start. Yep. So now B, what does B do? B, move ACC. Oh, wait, I don't even need this because it's the same code. So I can just jump back to A again. Then jump not equal 0. So in the way, if you think what's happening is I'm taking a left, and then here actually I'm taking a right. Yeah, so I take the value of left, okay, check if it's 0. If it's not 0, then move it down. Okay, if it is 0, then I check right. And if that's not 0 as well, then I move it, then I take the one that is the one in the middle here, which I added the two together. And that should give me the right answer. So let's just run this and see what happens. I'm got a feeling that this will have some errors. Yes, we have a problem here now. Move up left. Not a problem already. I'm not dealing with the 0 here. I have a 0 coming in. I'm not actually doing anything with it. Okay, we have an issue here. So the first one we got 13. Yes, because we are ignoring whatever that's coming in from the rest. So we do need a B. That will ignore the outputs of the rest. Okay, here we need to move. So this ACC is left. We need to move right to nil. And for B, we need to move left to nil. Just to make a bit more space, because I needed to jump back to start. JMP start. JMP start. I got a feeling this is not really gonna work well. JMP start. Okay, let's just run this and see. And we have an error again. So our issue now here is this is 0. Move up, down. Yeah, I knew this was gonna happen somehow rather, because now it's moving the value from up to down. That's fine. But I have an issue now that this 0 is coming in and nothing is accepting it and doing anything with it. Okay, this won't work. Hey, this is a bit more difficult than I thought. Move ACC left, move it to the right. Then if it's 0, or yeah, I think I know what I can do here. Basically, I can take out this whole part here and move it to the column below, so this comes down here instead. That could work. So B comes to this side. Okay. So let's take this. I'm gonna say start. I'm gonna move, first I'm gonna move up to ACC. So in a way, the up there compares those two. Okay, I'm not gonna move right anymore here. So, oh wait, let me just paste this back. I took the wrong thing. So move right ACC, jump to B. So I'm gonna take this whole part out. Okay, paste this here. Move up to ACC. Then I'm gonna have, no, not move right first. I'm gonna have A and B again here. A, Zach, A and B. Okay, I have to put the actual create the names for those again. Okay, it's like A, move up, down. Okay, I do not even need B. B is basically the final answer already, so I can move right to down if it's not A. Move ACC down, move right to nil, and move up, down. Anyway, it makes sense, yeah, okay. Then, move up, down. I need to clear the value that's coming from the left hand side. So move left nil. This will be actually moving it down. Move up left. And then move left to nil. So whatever's coming from left, if I'm taking the values up, I should move left to nil. Then nothing is going to come in from right, so I don't have to bother with this. And then GNZ A, I would probably have to do the same thing. Move up to ACC, GNZ A, and then A. So it's the same thing. Move ACC down and JMP start. Okay. And lastly, of course, I have to jump back to start again. Yep. So move up to the left hand side, and then so basically this two is basically a repeat of each other. Checking this, checking this, pairing it here. If not, take the top one. Then I'm doing the same thing here. I'm checking this, or else I'm taking the top one. Let's run it and see. Oh, I have a problem. Move up, down. See what's happening if I'm moving up, down. Up has no value. Right. So I needed the output as 0 if there's nothing as well. Move 0 down. So basically all of it I need to do that. Move up, down, so that it stays that it's 0 and don't bother with it. Still have an issue. Oh, the timing is all out. Move left to ACC, but it's stuck. I probably need to redo the whole program. Yes. Oh, damn. Right. Okay. I am not dealing with the problem that's coming in from B now. So if I move up to ACC and jump to A, Am I forgetting to clear nil? Move left nil. Oh, right, I forgot this. Right, let me copy this. So I need to actually move that to move right down. Move up, down. Move right down. Wait. I'm taking ACC and moving it down. Oh, I'm confusing myself now. Okay, I'm looking for left now. I'm looking up. Right, why don't I make them the same? Okay, this is right. I'm gonna move right to ACC. Okay, and then I'm here, I'm doing move left nil. Why am I moving left to nil here? If I'm moving left to ACC, it's in ACC already. Then I'm checking, I jump to A. So ACC itself is what they're supposed to be left. Why am I moving? This shouldn't be here in that case. I should be. Oh god, I'm confusing myself really. What am I even doing here? Okay. I take the value of left, move in the ACC, and then I check if it is 0. If it's not 0, I go to A. Then I move it down. In that case, whatever that is coming in from the other one, which is up. Yeah, okay. Now I think I get it. Move up to nil. So in that case, I will have to take whatever that's coming from up, move it to nil, because I don't want to bother it anymore. Because I'm taking ACC and moving it down. So in that case, what happens here is the opposite of it. Okay, so I take up and move it down, but I don't have to move it to nil here anymore because at left is already in ACC. So this makes sense. This doesn't need to be there. So the same thing happens here. If I'm taking right and moving in ACC, I jump to A if it's not 0. Then I move. Yeah, nil discards it. So I move right. Okay, no, I don't move right to down here. I move up to down. Up, down. So basically, in a way, this two is supposed to look the same. Only thing is supposed to be left and right. Different is that. And then I jump to start jump. Not jump J inside. This is JMP. So it is no matter what I jump. And ACC down, and then same thing here. Move up to nil. You know, if this doesn't work, I'm just gonna go and sleep because I can't think anymore. Run. And it seems to work until here. Okay, I got -19 to come out -19 here. Now where is it stuck? Move left to ACC. And nothing is coming in from the left. What? Okay, the first 5 answers are correct. Yeah, I think I'm missing something here. So yes, S is 1, but I'm on the 0 label. My ACC is 0 for some reason. Oh, I think I know why. I forgot to jump back to start here. So it always has been inside the 0. It's just basically just looping in. Wait, by right, if I don't jump back to start, it will go back to start. So that's not a problem. Yeah, I mean, if I don't jump to start, it will go back to start. No, that's not the problem, it's something else. Okay, let me just step through. Okay, no, I need to. Can I just run into that part? No, I have to step through. Okay, let's just step through all of it first. Until we reach about. Okay, here, okay, negative 19. Okay, move. Okay, this one works fine. Negative 19 comes out with the correct answer. So, okay. Okay. Negative 1. Yeah. Okay, negative 1, correct. That's what's in ACC. Move ACC to the right. So this negative 1 gets... Okay, negative 1 moves to the right. Okay, fine. So it's checking when it's negative 1. So, okay. Not positive. So move up nil. Okay. 0 down. It seems I have a timing issue. Maybe, no, let's see what is actually happening here. Okay, negative 19. Okay, negative 19 is what comes down here. Okay, that's fine. Negative 19 is the output. Yeah. Okay. So, okay, negative 9 is fine. Okay, now the issue is here. So what comes in after that is negative 17, 0, and 29. So yeah, it's correct here. Negative 17 is coming in, 0, 29. So they're coming at the same time. Okay, that's fine. Now what is happening next? Step through, move up to ACC. So 0 goes in there, that's fine. Then I'm moving ACC to the left hand side. So ACC, the left hand side gets the same thing. So it gets 0 there as well, okay? And then next, I move this 0 to the right hand side as well. So right hand side gets the same thing. Yep, okay, both of them gets it. Now on the left hand side here, move up nil. Yeah, I'm taking the value that's up there and moving it at nil because 0, it's not, it's supposed to, wait. Oh. Now I know what's the problem. I totally forgot about that. Hey, but no, that doesn't... No, actually no. If it is 0, this should be the one taking over. That's correct. Why am I moving 0 to left and right? Because... if it is negative 1, it wants the value of in A. So it this box here, this, I would call it what, this processor needs to know what is the value of S as well. Because the what's the requirement of this program is, if it is negative, I want int A as the output. If it is positive, I want int B as the output. If it is 0, I want the answer to be adding up A and B. So I need to move 0 to left and right because this 2 needs to know what is the value of S. So, okay, jump if it's equal to 0. So 0, it should come in here. That's correct, actually. Okay, so I'm gonna jump in and see. Okay, jump if it's 0. Then I move left into ACC. That's the part I didn't take into account, because when it is 0, I need to take back the output of A, come back here. Same thing here. If it is 0, if S is 0, I want back output of this and this to come back here so I can add it together. That's why it's stuck here, because the output from these two is not coming back here, so it can't add it. Nothing to add. What if we do the math on row 2? Row 2 of which? You mean the in S box there? So if I do the math on row 2, what do you mean by row 2? Which row 2? You mean the second row, what, the third column? Yeah, I've got a feeling actually that 0 calculation shouldn't be here actually. Be somewhere else. Where? Okay, that makes sense. Yeah, basically the first row shouldn't do any of this calculation stuff. Easier debug. You don't find A, you pass 0 down. Actually makes sense. In a way, each of this calculation should be done on its own row rather than everything. You know, actually I should do this with a more clearer mind. I guess I am not thinking properly actually. I honestly speaking, I have done this program before. This is not the first time me playing this game. Just I totally forgot how I did it. And I can't think properly now. Yeah, I think I should stop here. I think this is a sign that I should stop here already, and then I'm gonna redo this, that's for sure. I have to redo this program. Yeah, I'm not happy with this. I'll be back to solve this. Okay, I'm gonna end the stream for now. I really can't go on now. Can't think. 2-hour stream. Working a lot of things on today already actually, so. Well, thank you for joining in. I hope to see you soon. And I hope to really solve this. Actually solve the whole thing. Yep. Thank you. Good night.